Welcome to week 1 of our Introduction to Medical Software class. Here we will set the stage for what will come up for the next 11 weeks or so. This week we'll introduce what medical software is. We'll discuss relevant regulatory issues, and then Dr. Nikolai, my colleague, will come in and talk to you about these opportunities in medical software and digital health. And that will be the stage setter, and then over the next few weeks we'll take each of these topics and go into more detail. So we have a number of videos. We have 7 segments for you this week. The first 3 are just an introduction to the class and a guided tour of the medical software in 2 parts. We'll look at each of the stages of the process. Then we'll introduce the regulatory process. The last 3 segments will be from Dr. Nikolai. First, he'll talk to you about the US healthcare environment, how it works, why it's so expensive. And the last segment, he's going to talk about the promise of the digital transformation of healthcare. This is where medical software's potential to redefine how we use healthcare, how we run healthcare right now in the United States and around the world comes in. As I mentioned in every one of these lectures, and you'll see this slide over and over again, where this class is based on a textbook. You can see the picture of it there. And this week's material is based on chapters 1 and 7 of the textbook. Welcome to week 2 of our Introduction to Medical Software class, and our focus this week is going to be on the regulatory aspects of medical software. How are the regulatory agencies regulating software? What are the procedures one must follow? What is the process that they follow? And some emerging issues when it comes to things like artificial intelligence and machine learning. So this is the goals of this week's lectures. We'll discuss the history of regulation, the history of the Food and Drug Administration in the United States a little bit. We'll review some key regulatory documents. We'll describe the current regulatory process primarily in the United States, but we'll take a little bit of a look at both the process in the European Union and China. And then at the end, we'll have a short discussion of emerging issues in artificial intelligence and machine learning. So this is the outline. These are the videos we'll have. The first video is the mission history of the FDA. The next 2 deal with the old regulations, the quality system regulation and the guidance, the general principle of software validation. This will take us to about 2002. Next, we'll take a look at the documents from the International Medical Device Regulators Forum on software as a medical device. This is a regulation that comes out in the last decade, 2010 to 2019 or so. In the last 2 segments, we'll do a quick overview of the regulatory process, and we'll talk a little bit about emerging issues in artificial intelligence and machine learning. Again, we'll pick up the thread on those in week 11 when we revisit this topic. And as we'll mention every week, in this class we follow the textbook, and the material for this week is based on chapter 2 of the textbook shown here. Welcome to week 3 of our Introduction to Medical Software class, and in this week's lectures we will look at the clinical environment and the constraints that come with it. So both constraints that come from the environment itself, the doctors, the nurses, whoever, all the stakeholders are involved, and also the associated technology that is present there, the databases that we have to interact with, the electronic health records, the PACS, the imaging databases, and then issues to do with the regulations that are in this area, the data privacy and security issues, and the increasing emphasis on cybersecurity. So those are our topics for today. So this is what we'll cover. We'll talk about health environment software, what we need to interface with, data privacy laws and regulations, and as I mentioned before, cybersecurity. We have 6 segments here. First, we'll talk about the stakeholders. So I labeled these patients, doctors, and all the rest of them are involved. We'll talk about clinical information technology in 2 segments. The first one is the general introduction. The second one will focus in on medical imaging. We'll have a demo presentation of the imaging and the health records databases from Professor Miriam Aibon, a radiologist at Yale New Haven Hospital. And then the last 2 segments will talk about data privacy and cybersecurity. And in just like every week, the presentation here is based on the textbook, and here we're looking at material from chapter 3 of the textbook as we go. In this week's lectures, in this week 4, we're going to talk about 2 technologies that support the development of medical software. We're going to talk about quality management systems and risk management. So our objectives are to cover quality management systems and risk management. These are the supporting technologies that underlie all of this development. All the work in medical software happens within the context of quality management systems and under the support, under the guidance of a risk management procedure. We have 6 segments. The first one will introduce quality management systems. The next two will review this very important guidance document from the IMDRF on quality management systems. Then we'll introduce risk management, and then we'll have two more segments to describe the risk management process. For extra reading, you can go to the textbook to look at chapters 4 on quality management systems and 5 on risk management, and this is where the material in this lecture comes from. So this week we will actually start working on the design of software. We'll introduce the medical software lifecycle, the organizing principle for a software project, and over the next 5 to 6 weeks, we will work through the individual steps of the cycle. So today we'll do the big overall introduction, and we'll pick up each piece week 6 to 10, 11 of this class. So our goals for this week is to introduce software lifecycles. We'll discuss the IC 62304 standard, the international standard that governs medical software lifecycles, and we'll introduce our example project of image-guided neurosurgery, which we'll use to anchor our discussion of the steps in the software lifecycle, at least the first part of the cycle. The outline will introduce lifecycles and the standard in the first couple of segments. In the next 2 segments, we'll introduce the example project, the image-guided neurosurgery project, and we'll give a guided tour of the lifecycle process. And then the last segment, we'll talk about information transmission, this whole very important topic, so how information gets conveyed from the user to the business analyst, to the software developer engineer, to the coder, etc. We are still following the textbook, and this week's material comes from chapter 10 of this book. So welcome to week 6 of our Introduction to Medical Software class. In this week's segments, we're going to talk about user needs and the system requirement specification. These are the first 2 steps in the medical software lifecycle. So the goals of this lecture is precisely to discuss user needs and the process of how we go about identifying them, how we go about writing a system's requirements and coming up with what they should be. And we're going to show examples for our project, the image-guided neurosurgery project, of both the user needs process and the systems requirements process. There are 6 segments this week. The first 2 we'll discuss about how we go about identifying user needs. Then we'll talk about user needs for a specific image-guided neurosurgery example project. Then we'll talk about the systems requirement specification. We'll give you a template for that, one that I developed for my teaching needs. And then in the last segment, we'll talk about the systems requirement specification for our image-guided neurosurgery project. This week's materials is based on chapters 11 and 12 of the textbook, and we'll keep returning to the book as we go through. So welcome to week 7 of the Introduction to Medical Software class. And this week we're going to primarily focus on the process of designing the software, the actual conversion to create a plan that will go from requirements to something that now can be implemented on a computer. So here is the goals for the week. We're going to talk about software design. We're going to show an example for our project. Then we'll have a segment on usability engineering, how to design user interfaces to avoid user errors. And then we'll have a segment as an illustration. Dr. Nikolai will present a review of an industry sector on behavioral health and how software in behavioral health is changing how it is done right now. So we have the following segments. We'll describe the software design document. We'll show a template for this, just like we did for the system required specification. And then we'll have a section of showing how we create this document for our image-guided neurosurgery project. Then we'll have a segment on usability engineering, which is the design of the user interface for safety primarily. And then we'll have a segment from Dr. Nikolai, as I mentioned before, and this is titled The Impact Analysis of Emerging Digital Behavior Health Industry and how this is changing how behavioral health is done right now. This week's material is based on chapter 13 of the textbook, and as before, you'll find more details there, especially when it comes to examples of the details of this document. Welcome to week 8 of the medical software class, and in this week we're getting into the most concrete components of the medical software lifecycle. We'll talk about coding and testing, and in many ways this is the part of the lifecycle that is most similar to any other kind of software engineering you may have had exposure to. So for those of you who have a lot of expertise in software engineering, this will be a fair amount of revision, although we'll try to highlight some things that are unique to the medical software process. So the goal of this week's lecture is we're going to give you some advice on coding, especially in this medical software domain. We'll talk about source code management, we'll introduce software testing, and we'll discuss what a testing plan looks like. We have 5 segments for you. The first 2 are going to focus on code. First, the process of construction or programming, and then managing code and revision control systems. Then we'll do an introduction to software testing. In the last 2 segments, first we'll do an example of integration testing within the context of real-time fMRI, and then we'll do a final segment on verification and testing and thinking about how one goes about developing a testing plan for software. As before, we're following the textbook, and this week's material is based on chapter 14 of the textbook. Welcome to week 9 of our medical software class. This week we'll take a detour from the software lifecycle process to cover some mathematical backgrounds. We'll do some introduction to probability, statistics, detection theory, significance testing, and sort of the mathematical techniques needed to design a validation study. And then we'll pick up the software lifecycle next week when we talk about software validation. So the goal of this week, we have a detour from the lifecycle process. We'll introduce concepts from probability and statistics. We'll talk about the critical area of signal detection, and then we'll present some methods that are necessary to understand how clinical trials are designed. As an outline, we have 8 segments, 8 short segments. We'll have the first 2 talking about basic probability theory and introduction, and then we'll talk about multiple events. Then we'll have 2 segments on giving an introduction to statistics, the basic introduction, and then the process of estimating probability density functions. Segment 5, we'll talk about the critical process of signal detection. Did something happen? Do we have an event here? And then the last 3 are going to be a little bit of the foundations for clinical trials, a discussion of statistical significance and randomization. This week's material, if you want to do some further reading, is based on week 8 of this textbook. And here as a disclaimer, the next few slides compress material that's usually taught over many, many semesters. This is a very high-level introduction to the topic for those students that have no exposure to this before. There are many textbooks. This is the one I was taught from. This is the work by Papoulis and Pillai on probability, random variables, and stochastic processes. So there are many other books like this that you can also go back for more detail. So welcome to week 10 of our medical software class. Today we're going to finish off the medical software lifecycle. We're going to spend most of our time talking about validation, but then we'll have short segments on the back end of the cycle, deployment, maintenance, and retirement as well. So the goals of this week's class are to talk about software validation. We'll introduce clinical trials, and then we'll have some short segments at the end to talk about deployment, maintenance, and retirement. These are the back ends of the medical software lifecycle. So we have 5 segments. The first 2 will do an introduction to validation and then an introduction to clinical trials. In the third segment, we'll give some concrete advice for creating a validation plan. And then we'll do the back parts of the cycle. In segment 4, we'll talk about deployment. And segment 5, we'll at least highlight some issues involved in the maintenance and retirement of software. All of those last topics, deployment, maintenance, and retirement, are huge topics in their own right, but really beyond the scope of such an introductory class. This week's material is based on chapters 15 and 16 of the textbook, and we've been following this throughout this. Welcome to week 11 of our medical software class, and in this week's lectures we'll focus on artificial intelligence and machine learning, the use of these technologies, the challenges they produce as we integrate them into software, and the whole aspect of how one regulates these things. How do we create rules to ensure that the use of such techniques results in safe software that doesn't endanger their users and our caregivers. So these are the goals of this week. We'll introduce what machine learning is. We'll discuss deep learning, and then we'll talk a little bit about the regulatory aspects of the use of artificial intelligence machine learning in medical software. And finally, we'll touch a little bit on artificial intelligence machine learning as part of the software lifecycle. So I made the decision as we designed this class not to sprinkle AI/ML throughout the last 5 weeks, but to save all those issues for this segment here. So we have 6 segments. The first 2 are the basics. We'll introduce AI/ML techniques, and then we'll talk a little bit about the evaluation of machine learning methods and related issues. Then we'll introduce deep learning. Professor Nishat Vornik will come give a presentation on that. Then I'll come back and talk about the regulatory aspects. First, an overview of the regulatory guidance from other countries, and then we'll do a deep dive into the Singapore guidance for AI/ML, which is one of the better documents that's out there. And then finally, Professor Onofri will come in and talk about AI/ML and the software lifecycle. This week's material is spread all over the textbook. There's some in chapters 8, chapters 9, and chapter 15, but you can track it from the index if you want to do more reading on this topic.
Welcome. So in this section of our course, we're going to step away from the technical aspects that you've been learning and really think about how to get your medical software or your lab prototype out into the hands of people in the real world. It will be just as important to get a basic overview of the business side of things so that you can launch your venture. My name is Aisha Qureshi, and I'll be doing this section with Dr. Likolai. The goals of this section in this week's lectures are as follows. First, we will discuss the changing models in healthcare. Then we will go into the nuts and bolts of starting a new healthcare venture, a broad overview to speak. And then we will end with when and how to raise capital. As an outline of the lectures themselves, the first two lectures, presented by Dr. Likolai, will include value drivers in digital medicine, as well as changing business models in healthcare. I will then return to go through setting up a new healthcare venture, finding your first paying customer, and when and how to raise capital. For extra material and to follow along within the textbook, please refer to chapters 6 and 7 in our Introduction to Medical Software textbook.